So that's kind of just like exploring what's in there. But if you want like a really simple, some really simple code to like train a model really quickly, like messed up a little bit because you can see it was actually initially having a really good accuracy and actually it like steered off a little. So there's definitely some optimizations that can be made there. Then after running it,
what is the cycle?
Sorry, so the cycle is basically there's the idea that when doing this optimization, we try starting in like a certain spot and we're continuously like trying to optimize, and then we I believe we change kind of the location a little bit. It's something that's used to basically, well, partially to kind of trying to escape those local minima, so we don't get trapped in there. I'll get some more resources. I'll get some more links for that, like details into that for you as well.
And this is using a pre-trained.
Yeah, so this has used a pre-trained model. So this model is trained. Actually, that's a very good point. This is trained using ImageNet, which is like a pre-trained model on. Basically, there was like a ton of images that were all labeled and sorted and categorized, and like other like researchers have trained a model to like recognize like dogs, cats, like people, like all kinds of objects. And what we're doing really here is we're taking a pre-trained model and to focus on our specific problem. So this model was not specifically trained to recognize like images with pneumonia versus images without pneumonia. But this is the idea of what is called transfer learning, which is like a really powerful technique, is that when we have a neural net with a bunch of layers, once we have all those layers kind of learn a certain technique, like ImageNet, like learned how to identify a ton of different types of images, differences between them. And with transfer learning, we're just saying, we're taking this, we're just adding kind of like a final layer at the end that just decides, is this an image with pneumonia versus is it not? And this is how to identify all these other things. We're just telling it to focus on this specific problem. And there are ways though to, there are ways also to actually train those earlier layers as well. So
This is an example of supervised learning, right?
yes, this is an example of supervised learning because we already know ahead of time what the images are labeled as. But then when I'll actually just finish up with this piece quickly, is that when we actually go, I just wrote a quick loop here. All it's grabbing is some normal images and it's predicting on them, and some images with pneumonia. And 0 is normal and 1 is pneumonia. So you can see here, it got a couple of them wrong, and with pneumonia, it got none of them wrong. So it seems, and honestly, that's probably like actually best for us, because we'd rather not be missing anybody with pneumonia and like sometimes maybe misdiagnosing somebody than like missing people who, you know, have a sickness and saying they're okay, right? So you can see here, we categorized a bunch of these images and said, okay, well, this one was actually a mistake, this one was a mistake, but all of these are correct. So when we're going through all these, this is like a very base model, but basically we can do a couple of other things. Like for example, and I'll share like these Jupyter notebooks afterwards. I actually do have to clean them up a little just so that, you know, they're better for presentability. But basically, this is where we're using the learning. It has like the built-in learning rate finder, which basically just runs a bunch of iterations actually. Just plots like how the learning rate changes. You see here, there's like a kind of a bump, so we probably want to take learning rates around here and then use those, right? And there's a couple of other techniques in here afterwards that we can go over afterwards. But there's the idea we can have different cycles, kind of like gradient descent with restarts, where it's like kind of tries different positions. But actually, what you were talking about is this idea of having it pre-trained. And what we're talking about is transfer learning. Is that up until now, the only thing we've been doing is like certain patterns. Then as you go further and further, we can see that they learn how to detect, start to learn how to detect maybe a phase or something like